All right, here we go. Homework for 9-3, even problems. Starting with problem 20, write the first 5 terms of the geometric sequence. So A1 is given as 1, and from there we're going to multiply by a third. So 1 times a third is a third times a third is a ninth times a third is a 27th. We're multiplying by 3 in the denominator, which gives us our 5th term of 181. 30, write the first 5 terms of the geometric sequence, determine the common ratio, and write the nth term of the sequence as a function of n. So we want the first 5 terms here. So, got A1, A2. What we're doing here to get the next term, this is recursive. We use the previous term, the current one, and times it by a third. So a third of 81, 27. A third of 27, 9. A third of 9 is 3, and a third of 3 is 1. Okay, so we've got that pattern. Can we find the common ratio? Yep, we're dividing by 3, so r is 1/3. And write the nth term of the sequence as a function of n. All right, so we would want to use the a sub n formula. Which is a1 times r to the n minus 1. And so we know the first term is 81 times 3, I'm sorry, not 3, 1/3 to the n minus 1. We don't know what n is, so we'd have to leave that as a variable. But this would be our non-recursive formula for the recursive formula that we started with up here. Jumping to 40, write an expression for the nth term of the geometric sequence, then find the indicated term. In this case on 40, we're finding the 4th term. So, we have a formula here. A sub n equals a sub 1, r to the n minus 1. Let's substitute in. A sub 1 is 1, r is e to the negative x to the n minus 1. So that's our expression for the nth term. And if we set it equal to a sub n, it becomes an equation. And let's go ahead and plug in 4 for n. So we want to find a sub 4. 1 times e to the negative x to the 4 minus 1, which is to the third. I'm going to lose the 1 on the outside. E to the negative x to the third. And we can multiply or distribute in the 3 there, so it becomes e to the negative 3x would be our final answer there. 50, find the indicated nth term of the geometric sequence here. All right, so the first term for A7, we're going to want to figure out the first term, which is 8/5, times r. So we don't know r yet, but we can figure it out. What we're going to do is we're going to say the second term divided by the first term. All right, so we'll bring this up to the top and multiply by the reciprocal, 5/8. Let's do some canceling. That's a 5 and that's a 1. That's a 1 and that's a 2. So we'll get negative 2/5. Now, if we wanted to check to make sure it was geometric, we would also have to do 32 over 1/25 divided by 16 over 25. But they tell us it's geometric, so we know that this ratio is going to hold. So we have our ratio, negative 2/5. To the n minus 1, we know that n is 7 in this case, so to the 6th. So the 7th term is going to be 8/5 times negative 2/5 to the 6th. 8/5. Negative 2 to the 6th. 2, 4, 8, 16, 32, 64. And negative times to the 6th is going to be positive 64. And 5 to the 6th. 5, 25, 125, 625. Oh, I've lost it. Bring in the calculator. 5. Come back, calculator. To the 6th. 15,625. Okay, and so we can multiply these out. 8 times 64 in the numerator and 15,625 times 5 in the denominator. So 512 over 78,125. Big fraction would be our answer. Moving on to 60. Oh, sorry, we skipped 60 and 65 here. So moving on to 70. Let's find the sum of the finite geometric sequence. So if we bring up our formula again for the finite terms, right here, S sub n is the first term, 1 minus r to the n in the numerator, 1 minus r in the denominator. Want to be able to do this without using the calculator first, so we know the formula. So for 70, S sub n equals a sub 1 so 1 minus r to the n in the numerator and 1 minus r in the denominator. Alright, so we need to figure out what our first term is on 70. So let's plug in 1 here. If I go up here and just plug in 1, 1 minus 1 is 0. Anything to the 0 power is 1. 5 times 1 is just 5. So our first term is 5. 1 minus, and we're figuring out the 8th term here. 1 minus, let's figure out what the r is. What are we going to multiply each time in this problem? We're multiplying, starting with 5, we're going to multiply by negative 5 over 2. So our r becomes negative 5 over 2. Negative 5 over 2. And we're, in the numerator, raising this to the 8th power. Okay. So we can clean this up and punch that in, and we will get our answer. So let me flip this over. Actually, I'm going to trust you to plug that in and get an answer there on 70, just so that we can keep moving here. Okay, but that is the setup. So 80, same thing. Let's talk about the sum. In this case, it would actually be 7 terms, because we're starting at 0 and going to 6. So the first term here, if we plug in 0, we're going to have 500. Because anything to the 0 power is 1. 1 times 500 is 500. And 1 minus, what's our multiplier? Our multiplier here is 1.04 to the 7th over 1 minus 1.04. Plug that into your calculator, get yourself an answer, and that's how you set up 80. Moving along. 90, let's use summation notation to figure this out. Alright, so we're going to have something like this. X equals, we'll need a number on top, and we'll need a formula. So let's figure out what's staying constant. It looks to me, if I put a 1 underneath this, that the 3 is pretty much staying constant the whole time. So we're going to have 3 over something. The problem is this 15, and it looks like, what if we changed it to this? 5 to the 0, 5 to the first. Would this be 3 over 5 to the negative 1? Remember, negative 1 means flip it over, so if I bring 5 to the top, it's 3 times 5, which is 15. All right, so we're going to say 3 over 5 to the x, and we want to start with negative 1, and we want to keep going until 6/25 is 5 to the 5, 25, 125, 625, 5 to the 4th power. So that would be our summation notation for this sum. All right, 100, find the sum of the infinite geometric series. So let's flip back over and look at what that formula looks like. In this one, you're going to have a1 on top and just 1 minus r in the denominator, if it's infinite. Now remember, for infinite, we need to have a multiplier of less than 1. So it needs to be a fraction. We do have a multiplier of less than 1, 0.2 here, so we can go ahead and use that. So for 100, we're going to say the infinite sum is going to be a1, 4 over 1 minus 0.2, which is 4 over 0.8, which is 4 over 4/5. Flip it over, you're just going to get 5 for your answer. Okay, so 5 would be your infinite sum. 120, let's talk about annuities. We deposit P dollars at the beginning of each month, and we get an annual interest rate of R, compounded continuously, so we'll remember PERT is our formula here, and the balance A after T years is given by the formula below. Show that the balance is A equals the formula given there. Alright, so the balance is going to be the sum of all our money. So the sum after some amount of time equals A1. Alright, so how much did we start with? The very beginning was, did they tell us how much? Yes, P dollars is what we started with. So we started with P. 1 minus, do we have an R? Yes, we do. We have R here to the N over 1 minus R. Hold on one second.